Okay, so in this video, I will be explaining moment area method. So moment area method is a method which is used to determine the slope and deflection in any beam. In this method, basically there are two important theorems that we have to understand. So the first one is the difference between slope between 2 points. Let's say it is theta, the slope at theta point A is theta A, and the slope of point B is theta B. Like whenever the loading is applied, then the beam will bend and it will have the elastic curve like this. So this is the elastic curve. Okay, this is the elastic curve. And with respect to horizontal, whatever the elastic curve is making the angle, that is known as the slope. So let us say at point A, it is making a slope of theta A, and at point B, it is making a slope of theta B. So now, according to theorem 1 in moment area method, the difference between slopes between these points A and B, that is theta A minus theta B, equals area of M by EI diagram between A and B. So if that was the problem, then we will be drawing the moment area diagram. So there are two loads. Whatever the shape is. Okay. So whatever the shape it is attaining, say I will draw something else. So whatever shape it is getting, okay. So let's say this is getting a M, like this is the bending moment profile of any loading system. Let's say this is the loading system. Okay, and for this loading system we are having this bending profile. Then if this is point A and this is point B, then what is the difference between the slopes, like theta A minus theta B? It will be simply area of the moment by EI diagram. Like this is the moment diagram, and if we divide by EI, and the difference between slopes is this area only. So this is theorem 1. And according to theorem 2, so the like TBA, we will define one more term, TBA. What is TBA? Let's understand this first. So TBA is basically the projection of perpendicular projection from point B to the tangent which is drawn from A. So which means if we draw a tangent from point A, and if we project one vertical line to that tangent, so whatever distance or whatever like the portion it is we are getting intersecting, that is known as TBA. Like TBA, which means that projection from B and the tangent belongs to A. Okay, similarly if we do something like this, sorry, it should be a tangent. Okay, so, so let's say if I draw one tangent something like this, and if I project from point A and this is B, then this will be named as TA, that is projection from A and the tangent is from B. So we'll be naming it like this. So this TBA can be written as moment of M by EI diagram between these 2 points, like AB at where we are going to calculate. So first term, that is B. Okay, so at B. So if the CG of this figure is somewhere here, then this will be the like the moment of this area about point B will be the TBA. So now with the help of these two theorems, we can easily solve the problems. So we'll be looking at it, like we'll be solving some problems. So before solving the problems, I want to discuss one more thing regarding the area calculation and the centroid. So let us say that we have one curve which is having a relationship y equals k times x to the power of n, and we can have two shapes, like we can have this shape and we can have this shape. Okay, it is like inward and it is like outward, like concave, let's say concave, and this is convex. So if we are getting this type of like expression, then the area will be 1 divided by n plus 1 times b into h. Now here n, the value of n for point load, we are going to take it as 1. For UDL loading, we are going to take 2, and for uniformly varying load, we are going to take 3. This is happening because of the bending moment profile. For point load, the bending moment profile will be, this will be straight line, like x have a degree of 1, and for UDL, we are going to have the degree 2, like second degree equation, so n equals 2, and for UVL, we are going to have the third degree equation in the bending moment profile. So n1 2 3, you can remember like this also, or maybe if you want to like remember in the terms of loading, then for point load it is 1, for UDL it is 2, and for UVL it is 3. And regarding the centroid, the CG, so it is 1 divided by n plus 2 into b, and for this figure the area can be written as n divided by n plus 1 into b into h, and the centroid can be written as 1 divided by n plus 1 into b. Let's take example of point load. Let's say we have one point load, and so the point load will be making a triangular figure, a triangular BMD. So what will be the area if we calculate? So for triangle, so for straight line or maybe for point loading, so the value of n is 1. So 1 divided by 1 plus 1 into b into h. It is 1 by 2 base into height. So we know that area of triangle is this. So also from here, like what is the CG? So x bar equals 1 divided by 1 plus 2 into b, that is b by 3. We know it is b by 3 from this. So the formula is working correct. And you can verify from here also. If we put n equals 1, so 1 divided by 1 plus 1 times bh, that is 1 by 2 base into height, and here also 1 divided by 3 into b. So for all the cases it will work. Okay, so we can remember this. If we remember this, it will be easy for us to do this method, because we can skip the integration part, so we don't need to integrate it again and again. That will help us to avoid confusion. So after this, I will directly start solving problems. So let us start with a very basic question. So let us say that we have one beam which is simply supported, and let's say here it is one like roller support, and let's apply something like this. Let's say this is 50 kilonewtons. For the sake of simplicity, I'm keeping it very simple. Let's say this is 3 meter and this is 4 meter. And let's say this is point A, this is point B, and this is point C. And you have to determine theta at A, theta at B, and Y at C. So the first step will be determining the support reactions. So if we solve for the support reactions, we know that RA will be equal to, so 50 into 4 divided by 7, that is 200 by 7 kilonewton, and RB will be equals 50 into 3 divided by 7, that is equal to 150 divided by 7 kilonewton. So after determining RA and RB, the next step will be drawing the bending moment profile. So let's say the bending moment at point A is 0, the bending moment at point B is 0 because there is a hinge and roller support. And what about point C? So the bending moment at point C can be calculated as Ra times 3, that is equal to 600 over 7. Okay, 600 over 7. And as there is no load between like A and C and B and C, so I will be joining with a straight line, something like this. And here also I will connect like this. And this value right here is 600 by 7. And let's say that this was my 2EI, okay, and this was my EI only. Now, if I want to draw the bending moment profile, then what I have to do, I have to basically divide these bending moments with the respective EI and EI values. So here it is 2 EI and the span was 3 meter, and here it was like 4 meter and it was EI only. So 600 divided by 2 EI, that will give me like a lower value, that is 300 by 7 EI. Okay. And here 600 by EI only, so it will give me 600 by 7 EI. So we got our bending moment diagram. Now the next step will be drawing the elastic curve. So the beam will bend something like this for this problem, and if I draw one tangent here and if I connect that tangent with the projection, here the angle here is theta A and here it is theta B, and this will be theta. We are drawing the projection from B, so B, and the tangent from A, so here it will be A, and this is my point A, this is my point B, and this length is basically, and I will mark point C also. So let's say the C was here, so this length, this lower portion is T, I think it will be C and A here, and let's say this is my deflection YC, this point C. It is important to note that TBA was like below, like from elastic curve, what is the like distance up to the tangent. So not from entirely from C, but rather from this point. We will draw the TCA from this point, okay, from the elastic curve. Here also we are drawing from the elastic curve, not from point B. And if similarly, if we want to like find for like this region, then this will be my T. Let's say this is D, then it will be TDA, okay. So TDA, like let's say this is my A, so it will be TDA, this portion only, not the entire thing, but it is from elastic curve to the tangent, okay. So it is important to note this. So we have drawn this also. Now we will apply our theorems. So what was the first theorem? Theorem 1. So theorem 1. So it was theta A minus theta B is equal to M area of, okay, area of M by EI between A and B. So this is A and this is B. So this is my first theorem. So what is the area of M by EI between A and B? So can I write it as A1, and here I can write it as A2. So it will be A1 plus A2. And what is the area of A1? Isn't it 1 by 2 that is triangle into base that is 3 into height that is 300 by 7 EI plus what is the area of A2? It is 1 by 2 into 4 into 600 by 7 EI. So if I solve it, so I should be getting like 900 plus 2400. Okay, 900 plus 2400, 900 plus 2400 divided by 14 EI. So it should be 3300 by 14 EI. So whatever the value, if like I'm not trying to write it more like in simplified form, it is fine for me because I will be putting the values later. So this is my first theorem. And what is my second theorem? So theorem 2. So theorem 2 was about this TBA thing. So I will copy this figure. So I will copy this so that it becomes easy. So for theorem 2, it was regarding this TBA. So according to theorem 2, TBA is equal to moment of this M by EI diagram at point B. So I will write it, moment of M by EI between A and B at B. So this was my theorem 2. So it should be A1 into, let's say the CG of this A1 is X1. So A1 into X1 plus A2 into this CG of this A2 is X2. A1 X1 plus A2 X2. So what is this A1? So this A1 is 1 by 2 into 3 into 300 by 7 EI. And what is this X1? X1 for triangle. So let's just see the distance. What is this value? This is, let's say it is 3, then this should be 1. This is 1. Okay, I will use another pen. So this value is 1. And what is the distance between this and this point B? So isn't it 1 plus 4? So I can write x1 as into 1 plus 4, the total distance, plus what is the value of A2? It is 1 by 2 into 4 into 600 divided by 7 EI. And what is the distance? So the distance should be, so this distance, it is 2 into 4 by 3. So this is my distance. So from this I can calculate the value of TBA. So I will get some numerical value here. So I am not going to simplify it. So let's say that numerical value is X, because we can get the values now. Now, what will be the next step? So next step will be in triangle. Let's say this is B dash. In triangle A, B, B dash, tan theta A is equal to TBA by AB. Okay, and we know theta A is very small quantity. So for small angle theta, tan theta is nearly equal to theta. So it should give me theta A equals TBA by this AB. Now I know this like TBA. What is the TBA? It is X here. So whatever the value it is coming, I have wrote it as X. So I will get something X divided by AB is also a known quantity, that is 7. So I will get theta A. Once I get the value of theta A, then theta A minus theta B is equal to 3300 by 14 EI. So I can calculate this theta B. So theta B should be like theta A minus 3300 by 14 EI. So I will get the value of theta B also without any issues. Now let's talk about this YC. So for getting YC, what I will do, I will again use the second theorem, like TCA equal to moment of M by EI, moment of M by EI between, now this time CA, between C and A, where we are going to calculate at point C. So what is the moment of this area A and C? The area is A1, and what is the moment there? So isn't it 1 by 2 into 3? That is, the base is 3, height is 300 by 7 EI. So this is the area, and what is the distance? The distance is 1. So from here also I will get some known parameter. Let's say that is x1. Now what I will do, I will again take the triangle, in triangle AC. Let's say this is C dash, C dash. Again, if I say theta A is equal to YC plus TCA, okay, YC plus TCA divided by AC. Is there any issue? So I know the value of theta A, I know. So I have calculated this. I know the value of TCA, I know the value of AC. So I can calculate YC. So YC should be theta A into AC minus TCA. So this is how we can calculate the problem using moment area method. I hope with this a little bit of basics will be like cleared for you peoples. So for like practice problems, I will try to upload more videos. Thank you for watching.